Hello! In this video, we are going to prove the following theorem. Every subset of real numbers that has an infimum has exactly one infimum. Now, before we get into the proof, what is meant by infimum? Well, the definition that we're going to rely on is, given a subset of real numbers S and a real number W, we say that W is an infimum of S if the following two conditions hold. The first is that W is a lower bound of S. And the second is that for every lower bound W prime of S, W is greater than or equal to W prime. Right, so we can think of this as though it's saying W is the greatest lower bound of S. And that's the idea. So now, let's prove the theorem. And notice we're trying to prove a statement about every subset of real numbers, so give me an arbitrary subset of real numbers. I'll call it S. And from here we want to prove if S has an infimum, then S has exactly one infimum. So let's suppose that S has an infimum. So essentially, we have the existence portion. All we now need is the uniqueness portion. And so, to show that this infimum is unique, we're going to suppose that S has two infimums, W1 and W2. And our whole goal is to prove that W1 is equal to W2. Now to start, we know that by definition of an infimum, that W1 and W2 are both lower bounds of S. And next, if we take the W in our definition to be W1, then statement 2 holds for W1, right? We have that for all lower bounds W prime of S, W1 is greater than or equal to W prime. Well, since W2 is a lower bound of S, we can replace W prime here with W2. And we have that W1 is greater than or equal to W2. Similarly, if we take the W in our definition to be W2, then statement 2 holds for W2. So we have that for all lower bounds W prime of S, W2 is greater than or equal to W prime. Well, W1 is a lower bound of S, so we can replace W prime with W1, and we have that W2 is greater than or equal to W1. Therefore, since W1 is greater than or equal to W2, and W2 is greater than or equal to W1, these two facts together tell us that W1 is equal to W2. And this proves that this infimum is unique. So, S has exactly one infimum. So this completes the proof. And so yeah, that's pretty much it for this video.